right, so a lot of this stuff we know probably by now, but let's run through it quickly anyway. To print something to the screen, you use a cout statement. Cout is always followed by two less than symbols, and then you put what you want to print, and then if you want something else, you put two more less than symbols and what you want to print, so on and so forth. So assume I is the number 2 and j is the number 6. What will the following things print? So if I just put cout and then I put that variable name I, of course in your programs you will never ever ever use a single letter for a variable, but I'm the teacher so I get to do that. If I told you cout I, what would that print to the screen? It would print just the number 2. What if I told you cout I equals, with that in quotes, and then I? It would literally print the letters I and equals, and then it would print the number 2. And notice that in my cout thing here, I put some spacing to space things out a little bit. If you want a space after an equals to sign, you actually have to physically put a space there. The computer will not put it in for you. This one, cout sum equals I plus j. What's that going to print? Except it won't write 2 plus 6. It'll actually write the number 8 there. So again, within cout statements, you can print just variables, as we did here, and you can have the computer do calculations and print out the answers there too. So this would literally write sum, and then there would be a space, and an equals, and a space, and it would put the number 8. It can actually do calculations.
What happens if you try to do those types of functions without calling hashtag?
So what if you left the pound include IOStream off?
Yeah.
And you tried to do it, it would tell you that cout, it doesn't recognize cout as a command. It doesn't know what it is.
Even if you included the IOStream but not the CMath?
The CMath would be okay. Without CMath, the computer knows how to do 5 things: add, subtract, multiply, divide, and absolute values. So without the CMath, it will still add. It won't have any problems. Without the CMath, it would not do a power, though. So without the CMath, if I tried using the power command, it would tell me I don't know what that command is, and it would not compile. It would crash.
So it can't do absolute value without the math?
It can do absolute value without the math. Yeah. I think last time I might have said it only does absolute values of integers, but I tried it this morning and I was wrong. It will do absolute value of decimals also with just the command ABS. So it knows how to do absolute value. All right. How about this one? Cout j colon j I colon I. What's that going to print? It's going to print j colon 6 I colon 2. And notice it would be exactly like that. There would be absolutely no spacing because there are no spaces in the quotation marks. If you want spacing, you have to put it in. Okay. Now, notice we use quotations to tell it to just print these characters. What if you actually want to print the symbol quotation? You put a slash in front of it. That's right. So if you want to print a quotation, so you would have cout quote al. So it's going to print the word al. Slash quote will actually print the quote itself, and then it'll print the word Butch, and then slash quote Jones, and then end that. Okay. If you want a new line, we talked about this already. For us, so far, to get a new line, we've always used this endline command. There is another way to do it, and it's called using an escape sequence. So if I type in cout quote my name is, and then I put \n George Herbert, this would print my name is, and then on the next line it would print George Herbert. Okay? So if you have a long string of something in quotation marks, and you want to end the line, you can end it that way too, and then have it print multiple lines like so. Correct. So it's a neater way of putting or if you have one long sentence and it gets to the end and it splits one of your words right down the middle, you might want to use this escape character to put the next word on the next line. And rather than having to end your quotes, put the double less than, put another end line, put two more less thans, put another quote, and then start typing again. You can just use the slash n.
It is essentially a shortcut for the tutorial and well, basically.
Correct. But it only works inside of quotation marks. If I try writing something like cout I /n and then j, it's not going to know what that /n is, and that line will not compile. That /n would have to be inside quotes. So you wouldn't usually use it like that, although you could. Instead of putting quote /n quote, we would normally just put an end line there. But again, that's really your choice. Whichever way you want to do it will work. All right, so if you flip over here, just to look real quick, here are some other escape sequences that you might want to use every now and then. So for example, if for some reason you wanted to print a backslash, you actually put two backslashes. The first one tells it this is an escape character, the second one tells it this is what I want you to print. If you want the computer to go ding, it'll actually make a ding sound. That's a /a. Of course, the computers in the lab that we use have no speakers, so you can put that in there, you won't hear anything, but the computer's making the ding sound, it's just you don't hear it because there's no speakers. Yeah, it's a good thing they don't have speakers, and we'd have a bunch of dinglings, right? So on and so forth. So if you want spacing, instead of hitting, instead of hitting a space bar like 8 times in a row, you could use a /T to get a horizontal tab, and it'll give you however many spaces a tab is. I don't know how many spaces a tab is. Anybody know? I think it's 6. I think it's 5. I think it's 8. I don't know. Try it. But if you want to just do spaces instead of hitting the space bar a bunch of times, you can use /tab, and that'll give you a whole bunch of /T. That'll give you a bunch of spaces. Okay. Questions on those? Correct. Correct. If you type cout,
like earlier when you had to space out the date from actual date, /t, /t.
Right. But be careful. If you type cout name, and then you hit the tab button on the computer, it's going to move the cursor 5 spaces, but I think when it prints, the computer actually only reads that as 1 space. So it does, because you tried it. That's right. So if you want to move it 5 spaces or 6 spaces or however many spaces a tab is, you would go /T, /T, that would put 10 spaces or 12 spaces. Yeah. And then whatever else you want. I just want spaces, I guess. It won't show any different, but I just want spaces. Okay. Other questions? Carriage return. All right. That's an excellent question. What's the difference between carriage return and line feed new line? One of them only works on a typewriter. Okay. Good. Yeah. Today, the truth is, I don't think what you're going to see, I don't think these two commands are going to do anything different. The difference used to be line feed, if on an old typewriter, would simply go to the next line, but the cursor would stay in the same spot. So if you were halfway across this page and you did a line feed and you started typing, it would type in the same spot as you were before.
Whereas here,
Correct. Carriage return gave you a new line and put the cursor back at the beginning. Today, I'm not sure why there's two different commands there, but there are. It does have something to do with the computer and clearing the print buffer and some information about that, but I'm not exactly sure what the two differences are.
So it's like when you're typing and you press tab a bunch of times to get it out for, say, a bullet point list, and line feed would do is you keep typing, press that and you keep typing the same level out, whereas carriage return would bring you all the way back over to the original line.
Correct, except now this \n is also going to give you a new line and put you at the beginning.
Why?
It's not going to keep the indentation for you. I didn't make it. It's just the way it is. Okay? All right, back to the front side. We talked about cin also the other day. What does the cin command do? Gets input from where? From the keyboard. From the human. Well, the human types it on the keyboard. That's correct. As opposed to sometimes we have programs that read data from files. Later on in this course, we'll talk about how do we get the computer to read data from a file. If I have 10,000 things I need to type in, I don't want to sit there all day and have to type one after the other, after the other, after the other. I want to be able to dump it all to a file and have the computer read the whole big file at once. And there's a way to do that. We'll talk about that. That's a different command. All right. So we talked about cins and what they're going to do the other day. Sometimes you want to just read one thing. So this would read one number, the number 32. Sometimes you want to read more than one at the same time. And when you type them in on the keyboard, you can either separate them with a space, or you could hit 4 and then hit enter, and then 60 and hit enter on the keyboard, and it would read those exactly the same way. You can mix. Sometimes you want to type in letters and numbers at the same time. So J and K, you would be entering numbers. A would be entering a character, which in this case is the letter A. And again, you can type them in with a space in between them, or you can hit 25 enter, A enter, 16.9 enter. Since the first two are numbers and the middle one's a character, you don't even need spaces for that one. And it'll read 25 is a number, so it'll stop at the end of 25. And then it'll say, all right, next I want a character, so it'll read the letter A. And then next I want a number, so it'll read that number. So if you have numbers, you need to put spaces in between. If you have characters and numbers, you don't need spaces. And we saw that the other day in the program we wrote. We were inputting things like this, and we didn't put any spaces in between at all, and it knew. This is a character, and it held it, and then it read the number, and then it read the character, and then it read the number, and then it read the character. Okay? Now, this is kind of a weird one, so watch out for this when you're typing stuff in. If your cin only asks for 2 things, and you go ahead and type 3 by accident, the computer's not just going to delete that last one. It's going to save it. And the very next time it sees a cin statement, it's going to plug that in for that cin statement. So I've seen people do that by accident when they're running their programs and they need to type in like 3 numbers and they actually accidentally type in 4. And then later on they have a cin later and it said, the computer didn't stop and ask me to type in another number like it should. Well, that's because you typed in too many numbers to begin with. So that's kind of weird that the computer doesn't just ignore it. It actually saves it, and it'll hold it, and it'll type it in the next time it sees a CH, or a CN.
Is there any way to verify the number of inputs that are given so they can be, oh, no, 3 inputs and ask you again?
Yes.
How would you go about that?
How would you go about doing something like that? In order to do that, we need to know information about if statements. And then we would need to know something about looping to tell the computer to go back and do it again. We will get to that. We're not there today, unfortunately. We're going to talk about if statements here in a minute. And I saw that you were putting if statements in your program already that you were doing today. Yeah, he's like an advanced programmer. He's using stuff we haven't even covered yet. So. Other questions? All right, so up to this point, all the programming we've done, everything we've written, we work in sequential order, which means the computer starts at the top and it runs the first line. Then it runs the second line and it runs the third line, and it keeps going right down in sequential order, doing things one right after the other. Sometimes you don't want that. Sometimes you want to be able to say, test something. And if that something is true, I want you to do one thing. And conversely, if that statement is false, I want you to do something else. And that's called branching. And branching is traditionally done using what are known as if statements. So for example, the other day, when we were typing that program, somebody and we wanted to input things this way. Somebody pointed out that, would the person really need to type a parenthesis right there? With the program we wrote Thursday last week, where we were inputting points and we were finding the distance, somebody pointed out that the person could really put anything right there, and the computer would just read it, and it wouldn't do anything with it. And then the person types a number, and that would be fine. And then the person was supposed to type a comma, but maybe they didn't. They could type the @ symbol right there. The computer wouldn't care. And then another number.
Let's say instead of typing parentheses, you type a number.
That would be okay.
Let's say they type 5, comma 2, 2.
That would still work, because the first thing that we asked it to read was a character. A character can be a number. Now, be careful, if you typed 5, 5 and didn't put a space in between them, then you might have a problem because, well, it still should work, because it should read the character, it should read just that first 5 as the character that we were supposed to type in for that parenthesis. The difference is in how it saves it.
In math classes, is it correct to put a space after comma?
You can. We don't normally, but you could. No, we don't usually put a space, but you could. Anyway, so maybe it would be nice if, the person was supposed to type a parenthesis like this, and they typed a parenthesis like that. A bracket, correct. Maybe it would be nice if the program told the person, you typed the wrong symbol. So that's why you might want if statements, to tell people when they made a mistake in their input. That's no good. All right, so let's see how if statements are going to work. All right, so to type an if statement, you're going to type the word if. That makes sense. And then you're going to put a parenthesis, and then you're going to have an expression, something that you want to test. So what kind of thing might you want to test? Okay. That's much more complicated than what I was looking for. I was just looking for something like, you might want if x is greater than 2. So maybe the person typed in some numbers, and if they typed in a number bigger than 2, you want it to do something. What if they typed in a number smaller than 2? Maybe you want it to do something else. That's correct. So, oh, that would be a great one. So if it were a division problem and the bottom number they typed in 0, you would want to flag that, because then the computer's not going to work correctly, is it? You can't divide by 0. So you'll have the word if, then you'll have a parenthesis with inside whatever you want the computer to test, and then next you'll have a statement. So if x is greater than 2, I want you to do something. Maybe I tell it x equals 5 times x. Now, I've found in the past that statements like this really bother people who are new to computer programming. Because in math, we wouldn't normally do this. We wouldn't normally write x equals 5 times x in a math class. What's the computer going to do right here? And then what's it going to do with it? No, it's only going to do it once, because this command is only there once. So let's say x is the number 7. So if x is the number 7, is x bigger than 2? Yes. So what's this line going to do? X equals 5 times x. It's going to take 5 times 7, which is 35, and then store it as x. So if x is originally the number 5, after this line runs, x is now the number 35. So it does the calculation, and then it stores it back in the variable. So that's a little bit weird at first, that you can do calculations on a variable and then say, well, now I want that variable to be that new number. But you can do that. That's what that would do. You could, but then you'd need to make a new variable. Maybe there's a reason you want to multiply that variable by 5 and still call it the same thing. That's going to get to you. All right, it takes a while to get used to. Now, sometimes when your if statement is true, then you want the computer to do more than one thing. And if you want it to do more than one thing, then after the if, you write a curly brackets. So for example, I might write if x is bigger than 2. And notice there's no semicolon at the end of this line. That's a really common mistake people will make. They'll put a semicolon right there. No semicolon after an if statement. Then I'm going to put a curly bracket. X equals 5 times x. Semicolon. See out. X is now x. And then end the curly bracket. All right, so once again, if x is now the number 7, and the computer comes along, it sees if x is bigger than 2. Is x bigger than 2? Yes, because I just told you x is the number 7. So if x is the number 7, what's it going to do? It's going to take 5 times 7 and say that's 35, and then it's going to store that into x. So after this line runs, what's the value of x? X is now the number 35. So then it's going to print x is now, and then it will actually print the number 35. Okay, so if you want more than one thing to happen after you do your if, you put it inside curly brackets. All right, so now, what do you do if you want the computer to do one thing if your expression is true, but you want it to do something else when your expression is false? Well, you use what's known as an if-else statement. So, if expression, so if whatever inside the parentheses is true, it's going to run this line. Else, if this thing was false, it'll run that line. And you might remember we saw that in that very first program that we typed in. I had a line that looked something like this. If, well, go ahead.
When programming on a graphing calculator, it's actually the same thing, except it's just called an if-then statement.
Graphing, different languages use slightly different syntax. You're right, the graphing calculator uses a different language called BASIC. And in BASIC, it's called if-then, not if-else. Yep. So anyway, the other day I think I had something like if maybe bottom equals 0. And I told it see out. Can't divide. Bottom is 0. And then I think I had like an else. And I might have had see out the answer is top divided by bottom. And these squiggles here, these are just, the teacher wrote the wrong thing, so ignore these. Those are nothings. So what's this going to do? It's going to test. It's going to see, is the bottom equal to 0? If the bottom is equal to 0, it's going to say, I can't divide. But if the bottom is not equal to 0, it's going to divide and it's going to give the answer. So that's very common that you use if and else. You do one thing when it's true and a different thing when it's false.
So for if statements, you use brackets, but if out, you don't use brackets.
Depends on what you need. When I do the if this is true and I want more than one line of code to run, then I would need it in parentheses, in the curly brackets. For the else, if I needed more than one line of code, I would need to put that inside of curly brackets also. So here I only have one line if it's true, one line if it's false, so I don't need curly brackets. If you have multiple lines, you need curly brackets. Why is that the case? Whoever built C, that's the way they chose to write it. It will work perfectly fine if you put curly brackets around these, even though there's only one line. If you want to always put curly brackets in, you always can, and it will work correctly. But whoever built it, they decided if there's only one line, I'm going to let the person be lazy and not force them to type those curly brackets.
Would I understand that instead of bottom or denominators?
Well, it would depend on what your variable name is. So in this little snippet of code here, my variable name is bottom. If you had called your variable name denominator, then you would have if denominator equals 0. Whatever you called your variable name.
It understands the variable, it doesn't understand the actual.
Correct.
You
Steven.
need the quotations after the top minus by bottom part.
Oh, teacher did a bad thing. Very good. There should not be this quotation right here. Why not?
Third.
Some of the computers see text out just like that.
Actually, the computer, it will give me an error and it won't even compile, because if I need a quote at the end, I need a quote at the beginning. But do I want quotes around top divided by bottom? No, I do not. Thank you, Stephen. You're absolutely correct. Teacher screwed up again. There should be no quotes right there. No quotes right there. Other questions? I thought there would be another question that would be obvious that somebody would ask. That was the question I was waiting for. Why are there 2 equal signs there? No? Okay. If I have just one equal to sign right there, it's going to take 0 and store it into the variable bottom. Is that what we want to do right there? No. What do we want to do? We want to test to see if it is equal. So again, the people who built C, they had to decide, I want one symbol for store, and that's the equal button, equal symbol. I want a different symbol to test to see if things are equal, and they chose 2 equal signs. And I'm going to tell you right now, this is a very, very easy mistake to make when you write an if statement. It's very, very easy to put 1 equal sign because that's what we're so used to doing all the time. And it'll work, but it won't give you what you want, is the problem.
Would if just using one equal sign, would it actually let you assign it?
Yes. Yeah, it will. Ah, good. We'll get to that in just a second. It's even worse than would it assign it. So here's what would happen. What the computer does. The computer, right now, it tests this statement. If bottom equals 0. If that is false, then it takes this whole thing and it calls it the number 0. So 0 is false. On the other hand, if it's true, it stores the number 1. It calls it the number 1. So what happens is, the computer tests this. Is bottom equal to 0? False. It stores, remember, computers can only store zeros and ones. That's all it knows. It knows binary language. It calls this 0, which means it's false, which tells it to skip to the else statement. So, if you did this, if you wrote if bottom equals 0, it's going to take 0, store it into bottom, and then it's going to look at it and say, that's the number 0, so it's always false. So that's a really bad thing if you forget to use the double equal to sign. Especially if you have a 0 here, it's going to read it as always false. It'll never be true. It'll take a 0, store it into the variable bottom, then it'll say, well, it's 0, which tells me false. So always jump to the else. Always jump to the else statement. So be very, very careful of that. When you are testing, it's always double equal to sign. And I'm going to tell you that every now and then when I'm writing programs, I forget to do that too. And then I'm wondering for half an hour why my program doesn't work. Simple little thing like that. It will compile, it will run, everything looks great, and you get the wrong answer. Crap, what did I do? All right, so somebody asked, how do I get other symbols? If I want equal to, I use 2 equal to symbols. If I want not equal to, I put an exclamation mark in front of an equal to. So exclamation equals is not equal to. Well, I could put if bottom is not 0, and then I'd have to flip my 2 statements. If the bottom is not 0, print the fraction is, and then I would need else, print I can't divide. You gotta watch that.
So like the if statement always has to be here, and the else statement if bottom equals 0, not equal.
You do not need an else. You can have an if all by itself. Typically, you have an if and then an else, but you don't have to. You can have just a single if. So maybe you want the program to do just something special if the person typed in the number 7. And if they typed in any other number, you don't care. So you have an if statement that says, if the person typed in the number 7, say, congratulations, you picked today's lucky number. And if they picked anything else, the program just keeps running and it doesn't do anything. So, all right, so anyway. Test for equal is double equal. Not equal is not equal to. Greater than is greater than. Less than is less than. If you want less than or equal to, you use less than or equal to. If you want greater than or equal to, you use greater than or equal to. No spaces in between those. Just like that. Sometimes you want to test more than one thing at the same time. The word and, if you want to use the word and to test 2 things, it's double ampersand symbol. On the other hand, if you want to test or, then you want to, I don't know, what do you call those? It looks like an 11, but those are not the numbers 1. They're like the absolute value symbols, except again, you don't put a space in between them. But yeah, it looks like an 11, but those are not 1s. They're not L's either. Those are, on the keyboard, you'll find a slot where it has a straight vertical bar like that. Okay. Right above the shift. I don't know, I have to look on the keyboard. You're right. And then you have to shift to get it, too. Yeah, it's on the same thing as the backslash. All right, so flipping over here. All right, so we've created some code, and in this code, 2 gets stored to the variable x, and 3 gets stored to the variable y. So it comes in here and says, if x is less than y. Is x less than y, yes or no? Yes, because 2 is less than 3. So this is true. So what's the computer going to do? It's going to run the cout statements, and what's it going to print? print x equals 2, y equals 3, just like that, won't it? Because I did not put an end line at the end. So it will print them straight across. Is that what I intended? Probably not. And again, that's a pretty easy mistake to make, but nicely, it's a pretty easy one to fix. When you do that and you realize, oh crap, I should have put a new line there, then you go back and you put a new line there. Not a big deal. All right, so x is still the number 2. It says, if x. See out, the value of x is non-zero. So if x is the number 2, if x, what's that going to do? Do nothing? Well, it was either that, or it's going to print the value of x is non-zero. I mean, those are the only two choices, correct? It'll print it? Why will it print it? Correct. The if statement right here looks for a 0. If it sees a 0, then it's false. Did it see a 0? No, what did it see? It saw 2. So it's going to say, okay, that's all right. It's not 0. I'm happy. I'll run this line. So it's actually going to print the value of x is non-zero. All right. This is kind of a weird one. If x is less than y, temp equals y equals x equals temp, see out x equals x, see out y equals y. So, is x less than y? Yes, because 2 is still less than 3. So, temp equals y. So what's the value of temp going to be right there? So right here, temp will be 3. And then it says y equals x. So what's that going to do? Y is now going to be the number 2. So this line is going to take and it's going to make y equal to the number 2. X equals temp. What's that going to do? It's going to make x equal to 3. So then it's going to see out x equals 3. And then it's going to go to a new line. And it's going to see out y equals 2. All right, so that's a fancy little block of code. What's that fancy little block of code do? It just switches x and y. Why do I need this temp stuff in it here? It could have been anything. Only one can be stored as the other at a time. As soon as I say y equals x, then I don't have the value for y anymore. So I need to store it temporarily into a different variable so I can keep it to switch it later.
You said x equals y, would it do the opposite?
Right, at this line, if I said x equals y, when this line ran, it would take x and make it equal to 3. Right, so again, this is a little confusing compared to the way we normally do things in math. When you have a statement like this, it does all the math on the right and then stores it to the answer. In math, we tend to write it different. We tend to write 5 times 2 plus 3 equals 13. So we tend to put the answer on the right in math. In C programming, we put the answer on the left and we do all the calculations and then we stick it back in there. So again, that takes a little while to get used to. All right. Temp is just a variable that we're using to temporarily store the value of y so we don't lose it. So temp must have been an int variable declared somewhere up above in the program. But that's all it's for. It's a temporary variable to hold that value for y so I don't accidentally erase it.
So you don't erase it, but it's able to be modified.
Correct. Yep.
So by introducing temp, did you later in the program choose the variable
I could. I could use the variable temp later on in the program too. And it could be equal to something else too. It doesn't have to be 3 anymore. It could be negative 58. Yeah, you just have to write another line. All right, how about this line? If x is less than y, what's that symbol? That's the word and. So if x is less than y and y does not equal 3. So is x less than y? Yes. Is y not equal to 3? No. Y happens to be equal to the number 3, doesn't it? So what's this going to do? If x is less than y and y does not equal 3, the whole thing is false. It skips these next two lines. It doesn't run them at all. So when you use the word and, both of these things have to be true in order for it to be true and for it to run the code. One of them is true, one of them is false. It skips these. So what's this going to do? Absolutely nothing. It's not going to print anything at all. Now conversely, this one says, if x equals 10, or x minus y is less than 0. Does x equal 10? No. Is x minus y less than 0? Yes, because x is 2 and y is 3. So this one has this or that. What has to happen for an or statement? One or the other, or both could be true. That would be okay too.
Link the goals together and 4 or 5 additional.
Absolutely, you can. You could have this or that or that or that or that. You can have a whole bunch of them, and only one of them needs to be true, and it'll work.
What if you want to have one of those options be an and statement? You can have just one be an and statement, or want all of those.
All right, then you have to be careful. If you're going to mix and statements and or statements, you need to be very careful. And an or work kind of like the order of operations. So you'll sometimes need parentheses around certain blocks of that to make it do what you want it to do. And I'll give you an example here in a minute. All right, anyway. If x equals 10 or x minus y is less than 0. So this is true because one of them's true. We have a new symbol here. X plus plus. We haven't seen that before. Anybody happen to know what that does? It adds 1. So this statement, instead of writing this statement, I could have written this. X equals x plus 1. So what that statement does, if x is currently 2, it's going to add 1. 2 plus 1 is 3. And then it's going to store that into x. So that's a shortcut notation for that line. Add 1 to your value and store it back in. And similarly, you can probably guess what y minus minus does. It subtracts 1 and stores it back into the variable. So again, I could have written this line of code, y equals y minus 1. Exactly the same thing. What's that? So it turns out, because x was 2 and y is 3, and then we run these, it's exactly the same code as switching to two variables. Yeah. But that's only because I started with 2 and 3. Had I started with 2 and 10, this one would not look like it switched to two variables. Yes. So if you want to add 5, you can do x equals x plus 5. That would add 5 to x. Or you can go x plus equals 5. So what that'll do is it will take x, it will add 5, and then store it back into x. So yeah, there is a funky notation like that too. I don't use that one very often because it looks weird to me. I'd rather write x equals x plus 5. But the x plus plus and the x plus plus does get used a lot because a lot of times you want to add 1. And when we get to looping statements and you want to add 1 all the time, we use x plus plus a lot. Correct. These two lines right here would do exactly the same thing. They would add 5 to x and store it back into x. All right. I think we're out of time. No, we got 5 more minutes. 5 more minutes. Anyway, I guess we got time to finish this one then. So this one was true, we decided. So this one's going to see out x equals 3, and it's going to say y equals 2. All right, so the last thing I wanted to talk about was, let's say you wanted if x equals 2, and I have a very difficult time writing the ampersand symbol by hand, so that's what this is supposed to be, and y equals, I just did a bad thing, y equals 5, or y is less than 1. Say if you're going to mix ands and ors. If I'm the computer right now, the way I read this is I read it left to right. So I start with, is x equal 2? Yes or no?
Yeah.
And y equals 5? Yes or no? No.
Or, but the and statement would also go with the other or too, right?
So first the computer would do these two. It reads the ands. So is x equal to 2? Yes. Is y equal to 5? No. So it's going to read these two combined as a no. And then it's going to read this one as an or. So
Well, no.
So this is also no. So it's going to read this whole thing as no. But the point is it's going to do it left to right. Maybe you really intended this if x equals 2 and still can't draw these things. Y equals 5 or y is less than 4. So like I say, sometimes you have to use a different set of brackets. So what this is going to do first is it's going to try the or statement first and then put it together with the and. So otherwise, ands and ors, it reads them left to right, works along. If you want these two combined as one test and then and it with the x equals 2, you will need to put a set of parentheses around it like that. Okay. And then another thing you might have to do, in math we write something like this a lot. In C you can't write that. So what you have to do is you have to write if -2 less than x and x less than 5. It will not accept it if you write it as one statement across. That one has to be an and statement. So watch out for that if you're trying to test inequalities in C programming.